So for this section, we're going to go over 8.2, which talks about trigonometric functions. And let's begin. So this is the first thing we are going to want to not only learn, but try to remember, just because it'll help you in the long run. So I don't know if I could enlarge this by chance, maybe? No, okay. I guess we're not. I feel like I could. Hmm. Oh, okay, here we go. Okay, so this is called the unit circle. And as you could see, we have both degrees and radians on here. The degrees are here. Oops, I don't want to do that. What is it? It's this one. So these are the degrees. And then we have the radians over here on the outside. And although it looks kind of chaotic at first, it's really actually simple to understand. So we have the degrees, degree of 30, degree of 60, that corresponds to a certain fraction. So for instance, 30 degrees corresponds to pi over 6, which gives you the x and y coordinate. In this case, it's square root of 3 over 2, comma, 1/2. And essentially, so we have 4 quadrants, but each of them are going to look pretty similar to the first one over here. So the only main difference is that over here, we have a negative in the x, and then if you go down here, we have negatives in both the x and y, and over here, we have negatives in the y. So yeah, I think maybe it looks chaotic at first, but it's actually pretty simple to understand. And I feel like if we do some problems, it will probably just help. Let's find sine over pi over 6. So how do we do that? Well, we said earlier that this is the x and y. And for sine, if you don't know, sine is our y value, and cosine is our x value. So if we're trying to find sine pi over 6, all we're doing is we're going over to pi over 6. We're looking at not the x value, but the y value. And that is 1/2, so we put 1/2. And that's it. Okay, let's do another one just referring to the unit circle. Let's find cosine of 90 degrees. Okay, so we just said that cosine is our x value. So we're looking at an x value at 90 degrees. Well, 90 is up here. And if we look at the x value, well, it's just 0. So that's what we put. Okay. I feel like we're getting the hang of it. Let's do cosine of negative 90 degrees. What does that equal? Now, when you look over here, we have 90 degrees, but then you're like, okay, but where is negative 90? And all you do is you just go over here to 90, and you look at the direct opposite of that. So direct opposite of 90 is going to be 270. And then cosine, we're going to be looking at our x value, and that is also 0. And that's our answer. So that one seemed pretty easy, but if you ever get one that wants you to find the negative value of like 135 or 60, like all you do is you just go to the opposite side, and that's where your answer will be. Okay, let's do another one. Get the hang of it some more. Let's find cosine of 5 pi over 4. Okay, so cosine, we're going to be looking at the x value. Let's see, 5 pi over 4. Okay, that's going to be down here. It's going to be negative square root of 2 over 2. So negative square root of 2 over 2. Nice. Okay. So a lot of the homework just keeps asking questions about, finding the exact value of, like, let's say sine over pi over 2, or like 180 degrees. But let's see if we could do some problems where you need a calculator. And we're just doing this because in lecture we did go over a few problems, so I feel like that might be on the exam as well. And it's also like useful to know, just using your good old calculator. So let's see. We'll do two. Let's do sine of 10 degrees. So we already know that sine is our y value, but when you, like, let's go back, find 10 degrees. Okay, it'll be somewhere around here, but we don't have that answer. So that's when we're going to use our calculator. And all you're going to do is I'm going to type in sine 10 degrees, but you want to make sure that your calculator is in degrees and not radians. So I actually have to switch mine back really quick. Let's see, a second. Degrees, okay. Sine of 10, that is going to be 0.173648178, or we could just say 0.173. Let's see, that's a 4, so that's just going to say 6. Let's do one more. But this time we're going to use radians. So let's do cosine of 1.56. I'm going to change it on our calculator back to radians. Cosine of 1.56. That's just going to be 0.8. 0.7, or we could just say 0.8. And yeah. Okay, let's look and see what else we have to cover. Okay, so I think the only other thing that might be helpful, especially in this section, is just understanding the graphs of sine and cosine. So let's just go down here. Do sine. I'm gonna try my best to make this somewhat coherent. Okay. So basically, the graph of sine is going to look a little bit different than the graph of cosine, and that's okay. For the graph of sine, we go back up here. For our y, we just see that it goes from 1 to 1, so 1 to 1. And then it's going to start 0. We're going to put in 2 pi, 3 pi over 2, 2 pi. And then it's going to start from 0. It's going to go right to 1. It's going to go back down through pi. It's going to go to -1 and back up to 2 pi. And that is our graph of sine. The domain is infinity to infinity, range from -1 to 1, and this would be considered an odd function. Oh, and the period is just 2 pi, because that's where we ended. Now we will do cosine. Oops, I think that's a bit off. Yeah, that's off. Cosine. And this one's going to be a little bit different. I'm going to do 1, -1, pi over 2, pi, 2 pi over 3, and then 2 pi. This one's actually going to start at 1. It's going to go through 2 pi. Going to go down to -1. Going to go through 2 pi over 3, so it's going to go up. And it's going to go back up to 1. Okay, that looks a little bit more janky, but you get the idea. It's just a little bit different compared to our sine graph. For this one, it's going to be mostly the same thing, domain -infinity to infinity, range -1 to 1, but this is going to be considered an even function, and then the period is also going to be 2 pi. And this is just because, like, if we had another one, let's say over here, it will look like an exact mirror of itself compared to over here. That's how I think of it as. But yeah, I believe that's it. Yeah, thank you for listening.